So 3, 6 absolute value functions. We have done some things with absolute value functions before. What we're going to concentrate on in this section more than anything is the actual graphing of them. So we have solved some absolute value equations. So there are a few of those in here. We'll do those, but let's focus mostly on the graphs. So the absolute value function, remember when we learned our parent functions, is actually a piecewise function. There is a piece of it that is positive x. It's like the linear function y equals x, but it's only starting from 0 to infinity. And then the other one is the linear function y equals negative x from anything that's less than 0. So that is how the absolute value is defined. Now let's think about it for a minute. If it's a positive number bigger than 0, the absolute value does absolutely nothing. So you notice it doesn't change it. But if we try to plug a negative number into an absolute value, it makes it the exact opposite. Okay, so that's why that negative is there. And so that's why it's defined. This is a sloping line of a positive 1 slope, and this is a negative 1 slope. And they meet up at 0. And you can see they have a border and they meet up at 0. So that is what an absolute value function looks like. It's going to make a V. And that's going to happen in most of your absolute values. Now you could put an absolute value around a cubic, a quadratic, and other functions. And all it's going to do is any portion of the graph that would have been negative, it flips and makes that portion of the graph positive. So an absolute value, remember, it does nothing to positive values. It only takes negative values and makes it the opposite of what you want. So to graph an absolute value function, you're going to set the inside equal to 0. You're going to plug in that value and a minimum of 1 above that and 1 below that. And then you graph the points that you find to make a V. And that plugging the inside equal to 0 or setting the inside equal to 0 is a very good tactic for most of our parent functions. So as we learn about transforming and moving and changing all of our parent functions, we will find that that's a really good tactic to use. So set the inside equal to 0. Whatever you get, you're going to plug in that value, 1 above it, 1 below it, and the graph the points you need to make a V. Okay. So if we look at these ones at the top, so here's our parent function. Let's look at the different things that can happen to our function. So you'll notice here, this has moved to the right 3 by having this -3 on the inside. And what we're going to find the pattern is if you subtract on the inside, it will move it 3. If we add on the inside, it will still move it 3, but subtracting on the inside will move it to the right. Adding on the inside will move it to the left. Put in a number on the outside of the function. What it will do is it will stretch it. It will make that slope become that number, and so we will explore that as we go. But the same thing holds true no matter what. Set the inside equal to 0, plug in that point, plug in 1 below it, 1 above it. Now here's something I found that people do wrong with an absolute value. It is the absolute value of the answer. It is always the absolute value of the answer, not the absolute value of the pieces. It is the absolute value of the answer, not the absolute value of the pieces. Okay, so please remember that. It is the absolute value of whatever's the answer is inside. So don't try to take the absolute value too soon. You're going to get one number inside, then do the absolute value. If not, you'll get something funky, okay? So be careful with your absolute value. So if we look at this example, it says, translate each graph as specified, and it says that the graph of the absolute value parent function is shown, and then we're going to translate it. Okay, so let's do what I talked about for each one of these examples. So our first example, you'll notice, if we set the inside equal to 0, we just get 0. So this one hasn't been moved left or right. This just has a normal old x inside. So where does x equal 0? Oh, at 0. And so for this one, we are going to plug in 0, 1 below that, and 1 above that. Okay? So if we plug in -1, let's think about what we're going to do. We're going to plug it in right here. So this one we're going to do is y equals the absolute value of x plus 3. If we plug in -1, it becomes a positive. Positive 1 plus 3 is 4. If we plug in 0, we get 0. The absolute value of 0 is just 0. Plus 3 is 3. If we plug in 1, we get the absolute value of 1 is 1. Plus 3 is 4. You know how a quadratic, if we pick the correct vertex, then we see that those numbers repeat on each side? The same thing should be true if you've picked the correct center for our absolute value. Yes? You sure? Okay. Okay, so let's graph A here, now that we have some points. We're going to start at -1. We're going to go up 4. Then at 0, we're at 3. And then at 1, we're at 4. Now, the paths of each side are perfectly linear. So however they line up, pretend like that's a line. And so this portion of it goes here. This portion of it goes here. Okay. And if you had to describe what happened, what that plus 3 on the outside of the function did is it moved the original, went up 3. And when we do 3, 5, we are going to explore how the placement of the numbers will do different transformations to the graph. Everybody okay with A? Okay, let's move on to B. Now B, when we set the inside equal to 0, we get -5. So here we're going to graph the absolute value of x plus 5. So that tells me that when we go to plug in values, we need to plug in -5, 1 below that, and 1 above that. Now remember, when you plug that in, you're going to get an answer inside the absolute value. Once you get the answer inside the absolute value, then the absolute value will make that thing positive. Okay, so let's plug in -6. If we plug in -6, we get y equals the absolute value of -6 plus 5. Get an answer of -1, and it is the absolute value of that answer. See the difference? We need the absolute value of that answer. And the absolute value of -1 is 1. If we plug in -5, we get 0. The absolute value of that is 0. If we plug in -4, we get the absolute value of 1, which is just 1. If you did this right, then these two should match if you have picked the correct point, vertex, whatever you want to call that, of your V. If you've picked that pivot point of the V correctly, then you should always get repeated values. If you didn't pick it right, it's not the correct value. If you don't get a V happening, something is wrong. Okay. Okay, so we're going to go over to -6. We're going to put a point at 1. We're going to go -5 is going to be at 0. -4 is going to be at 1. We're going to follow perfectly straight paths in both directions, one with a positive slope and one with a negative slope. And we can say that the original went to the left 5 units. So what we've just learned here is if you add something on the outside, it's going to go up. So if you subtract something on the outside, it will go down. If you add something on the inside, it's going to go left. if you subtract something on the inside, it's going to go right. And we're going to keep exploring those patterns as we graph. Any questions about our first two graphs? Set the inside equal to 0. That is your point of your V. Plug in something just below it, plug in something just above it. You got the graph of your absolute value. Any questions about those ones? Okay. Now, in this example, there are more things that have happened to our absolute value. So let's explore what those things are going to be doing. Now, I already know what those things are going to be doing, and as we do 3, 5 especially, we'll explore those as well. But what the negative out in front is going to do, it's going to flip our V upside down. This thing is going to move to the left 3, and this thing is going to move it down 2. And so, but you don't have to necessarily know that, as long as you remember, set the inside equal to 0, solve for that value, make a chart, plug in -3, 1 below it, 1 above it, you got your V, okay? Now you have to be careful because of order of operation, so I want to practice doing this. So if you were asked to do this in ALEKS, to make, your V, you're still going to do the same thing that I'm doing here, just on paper before you try to graph your absolute value. Okay, so let's plug the -3 in first, because that's our vertex point, whatever you want to call that. So if we plug in -3 for our x, we get the absolute value of -3 plus 3. We get an answer for inside the absolute value before we do the absolute value. Now be careful, we have a negative on the outside. That does not change anything. The absolute value still makes something positive, and then that means the opposite of a positive. Well, the opposite of 0 is still 0, and so you're going to get -2. Okay. Now let's plug in -4. I'm going to do it over here on the side. So we would get y equals the negative absolute value of -4 plus 3 minus 2. Now let's follow order of operations. We're going to get an answer inside of our absolute value first. So we're going to get the absolute value of -1 is what's in that absolute value. The absolute value of a negative becomes a positive, right? But there's a negative in front. What is the opposite of a positive? A negative. So that negative out in front has nothing to do with the absolute value. You do the absolute value the way the absolute value does, and that becomes a positive. If there is a negative in front, it's always then going to become a negative, because you're always going to say the opposite of that absolute value. The opposite of a positive is a negative. And so we get -3. Now, if we did it right, if we chose the correct vertex, the correct pivot point of our V, the point of our V, then when we plug in -2, we should get that same exact value. So let's try it. If I plug in -2, inside the absolute value, I get a 1. I get the answer, absolute value. The absolute value of 1 is 1, but the opposite of it is -1. -1 minus 2 is, oh my goodness, we did it right, -3. Okay, so that should always happen. And let's discuss what I know is going to happen so we can start analyzing it. If you add on the inside, it's always going to move the function to the left. If you subtract on the outside, it's always going to move it down. A negative out in front is going to flip it upside down. So I predict that this V will be upside down. The point of it will move to the left 3 and down 2. And so look where our point is. So if I plug in the point, the vertex, whatever you want to call it, -3, -2. If I plug in -4, remember I got -3. If I plugged in -2, I got -3. Oh gosh, look what happened. Exactly what I predicted. My V got flipped upside down. Its vertex point moved 3 to the left and down 2. Everything that we thought would happen is going to happen. But did you have to know that off the bat? No. Always just set the center equal to 0. Plug in one thing above it, one thing below it. You got it. Any questions about that one? A little more difficult because there's lots of pieces to it. Take it a piece at a time and you'll be fine. Let's look at this one. It says below is the graph of the absolute value translated from the following. Now let me make the prediction. This, when you add on the inside, we have found already that it should move it to the left. If we add on the outside, we should have found that it moved it up. But let's find some points just to make sure that we're not crazy, okay? You know I am a little bit crazy. So if we set the inside equal to 0, solve it, the inside has moved to -4, to the left 4, just like I predicted. We're going to plug in -4, -5, and -3. We're going to follow order of operations when we do that. Now let's plug in our -4 first. That's our vertex, that's our center, that's our whatever you want to call it. And so if I plug in -4 first, I get the absolute value of 0, which is just 0 plus 3 or 3. Hey, look, our vertex moved to the left 4 and up 3, just like I was thinking it was going to happen. Now let's plug in the thing below it, the thing above it. If I plug in -5, I get -5 plus 4. You get the number before you do the absolute value. So the absolute value is going to make -1 turn into a +1, right? And so we get 1 plus 3 or 4. Now when we plug in -3, we should get the same thing. We do. If you plug in -3, you get the absolute value of 1, which is 1 plus 3, which is also 4. So if you've chosen the correct center, then you should be able to find the path of your V very nicely. Okay, so let's go to the point -5, go up 4, -4 is up 3, -3 is also up 4. Our V is, it moved, as you notice, to the left 4 and up 3, just like I predicted. So if you add on the inside of a function, it always moves it left. If you subtract on the inside of a function, it's going to move it right. If you add on the outside, it's going to move it up. If you subtract on the outside, it's going to move it down. If you have a negative sitting directly in front of the function, whether it's a cube or a squared or an absolute value, it will always flip it over the x-axis, flip it upside down. Any questions about that one? Okay. So let's look at this one. So what's interesting about that -3 out in front? The negative's job is to flip it upside down. We discussed that a little bit. What the 3 does is normally it's the line perfectly slope of 1 or -1, depending on what side you're on. What that 3 does is it makes it steeper. So it changes the slope of the line of each side. But you don't have to know that. If you set the inside equal to 0, you get 0. So that one didn't move left or right. It still has a center at 0. So I would plug in 0, -1, and +1. So then I could find where the heck it's going and how steep it's going that way, okay? If you plug in 0, you get -3 times the absolute value of 0, which is -3 times 0 or 0. Let's plug in 1. You get -3 times the absolute value of 1, which is just -3 times 1 or -3. Now, if we did it right, when we plug in -1, we should get the same thing. Well, -3 times the absolute value of -1, you do the absolute value first. Then even if it's a negative on the outside, who cares? It's just a negative now times a positive, which is -3 again. If you chose the correct vertex, center, pointy point, these two should always match. If they don't match, either you did the algebra wrong or you have the wrong center. So let's go ahead and graph it. At -1, we are at -3. At 0, we're at 0. At 1, we're also at -3. So what happened? Well, one side is a slope of +3. The other side is a slope of -3. The center is still at 0, 0. It's flipped upside down, and it's steeper than it used to be. So the V is a little skinnier, and that's pretty common. Any questions about that one? Okay. Just let's see where we're at. We're almost there. Okay. Let's do this one. Now, hopefully you can predict what's going to happen. Our vertex is going to move to the right 4 and up 2. Or up 1, I'm sorry. That is a 1 there. Up 1. So how do you check? Well, just set x minus 4 equal to 0. Get your center. My center is at 4. So I'm going to plug in something below that and something above that. If I plug in 4, I get the absolute value of 0 plus 1, which is 0 plus 1 or 1. So if you plug in 4, you get 1. Guess what? The center moved to the right 4 and up 1, just like we predicted. If I plug in 3, I get the absolute value of 3 minus 4, or the absolute value of -1, which becomes a positive, which becomes 2. So if I did it right when I plug in 5, I should also get 2. Well, if I plug in 5, I get the absolute value of 1 plus 1, which is 1 plus 1 or 2. So remember, anytime you're doing absolute value, you have to get a singular value in the absolute value before you make it positive or negative, or do whatever you have to do to change it. So you'll notice those match. So go over to 4, go up 1. At 3, we're up 2. At 5, we're up 2. You'll notice that the slope of our lines are still +1 and -1. What has happened? Well, we have gone to the right 4 and up 1. Because there is nothing on the x to change the slope, there's nothing out here to change the slope, the lines are still going to be 1 and -1, but the whole thing just got lifted up and moved to the right 4 and up 1. Everyone good with that one? That kind of makes sense, right? Okay, so let's talk about this little chart. And this little chart, after we do 3, 5, will make a lot more sense, but I'll at least take you through it, okay? It says for each function, choose whether its graph opens up or down. So is the V opening up or down is all about the front number. If the front outside number is positive, it's going to go upward. So the upward ones, this is going to go upward, and nothing else is going to go upward. All the other ones have a negative in front of the absolute value. So this V is going to go down, this V is flipped upside down, this V is flipped upside down. And it's all about that front number, okay? Choose whether the equation with the widest graph. So remember how we did the 1 and the 3 in front made the V very skinny, made it very narrow. The higher you are above 1, or the absolute value of 1, the front value, the higher it is above 1, the skinnier it will be. Any one that is between 0 and 1 is going to be the widest. So if you look, the widest graph, the number that is closest to 0 out front. So here, that's the skinniest. Next skinniest. 3/4, which one is 0.75, 0.6? This one here is closest to 0. This number here is the one closest to 0. So that's the widest. The skinniest graph is this one because it has that 3 there, and that is the narrowest graph. We'll explore that more in 3.5. 3.5 has a lot of stuff in it, so we'll explore that portion a little bit more in 3.5. Yes? Yes, exactly. That's exactly it. Yep, that's perfect. Okay, we just have 2 equations to solve. We had done these before, so this will just be a little review. So anytime we have a little something that I think is important that we review, we will do that. So let's take a look at this one. You always want to get the absolute value by itself. So I would subtract off the 13 from both sides. 33 minus 13 is 20. Only once it's completely by itself do we do the 2 cases. So this might bring back a little bit of memories here. Case 1, remember, is where you just drop off the absolute values and solve. Case 2, you're going to set the absolute value equal to the opposite of the numerical value, because the absolute value of 20 is 20. The absolute value of negative 20 will also give us a value of 20. And then you just solve each one. So here, if I add 4 to both sides, I get 24. Here, if I add 4 to both sides, I get negative 16. So you will get 2 values many times. Think about our V. That is saying, where is the height 20? Well, if you look at your V, you could find that in 2 different places. One last one. So here, get rid of the 8 first by subtracting 8 from both sides. If you subtract 8 from 93, what is that? Thank you. Now, there's 2 different things you can do. If your front number 5 is a positive, you can hold it and just distribute it in. If it's a positive, bless you. But if both sides are divisible by 5, my suggestion would be just divide by 5. So let's divide both sides by 5. If you divide both sides by 5, you get the absolute value of u minus 4 equals 17. Okay. Now, once you get that, then it looks very much like the problems from before. Okay. We're going to set 2 cases, case 1 and case 2. Case 1, remember, you just drop off the absolute value. Case 2, you drop off the absolute value and then you set it equal to the negative number option, okay? Because the absolute value of 17 is 17 and the absolute value of negative 17 is also 17. And then you just solve each one. This one we're going to add 4 to both sides. This one we're going to subtract 4 from both sides. And, when we add 4 to both sides, because that number is a negative and 4 is a positive, you would get negative 13. Now you can plug those back into the original form. I would go all the way back to that form to check that you're right. Plugging it back in is a good method to just get used to checking your work. Do we have any questions about the equations? Okay. So your homework, you've got 4 graphs to graph. You have 4 equations to solve. Or no, those are 6 equations. So you have 10 problems to do, 4 graphs and 6 equations. And the 3-6 homework I have posted, it will be due on Monday because of where the grading period is ending. Everything this week says Monday, okay. Except Alex. Alex, this is like a 2-week Alex instead of a 1.